All right. Um, One of the components of the principles of engineering test is probability. And for the most part, probability is pretty simple because they're going to ask you what's the probability of choosing a queen out of a deck of cards. So it'd be four queens out of a deck of 52, so 4 out of 52. Or they'll say things like, what's the probability that you roll a 4 on a die and then a 2? And so getting a 4 on a die would be 1 out of 6. Getting a 2 on a die would be 1 out of 6. And so it would be the product of 1 over 6 and 1 over 6. Um, so you're used to those probability problems because you've seen them in math class all the time. You may not be familiar with a probability problem, a conditional probability problem that requires you to use what's called Bayes' theorem. Bayes' theorem is actually quite simple if you create a table for the problem. And so conditional probability changes things up because you know something already. You're given some fact that changes the odds or the probability of an event occurring. For example, what's the probability of getting a queen in a deck of cards is, well, you have 4 queens out of a deck of 52, so 4 out of 52, so that's 1 out of 13. But what if we knew that the card that you'd chosen was a face card? So you're given that piece of info that says, you know what, I already know it's a face card. So I've got jacks, queens, and kings as face cards. And so that's a total of 12 cards. So if I chose a card and I knew that it was a face card, then the probability of it being queen would be 4 out of 12 instead of 4 out of 52. And so that changes my probability. So here's another conditional example, but it requires a little bit more calculation to get it just right. So I have 3 vendors A, B, and C, and they supply LCD screens at different percentages. Vendor A supplies 60%, vendor B supplies 30%, and vendor C supplies 10%. And each of these vendors has different percentages of defective parts. So vendor A has 0.7% of their components are defective, 1.4% of vendor B's parts are defective, and 1.9% of vendor C's components are defective. So then the question is, if a cell phone was chosen at random and the LCD screen was determined to be defective, what's the probability that the LCD screen was produced by vendor A? So if I was asking what's the probability that a LCD screen came from vendor A, that would just be 60%. But the fact that I know that it's defective changes things up a little bit. So let's make a table because that's probably the easiest thing to do for this type of problem. And so I have 3 vendors, vendor A, vendor B, and vendor C. And they each supply different percentages of this manufacturer. So vendor A supplies 60% or 0.6. Vendor B supplies 30% or 0.3. You have to excuse my handwriting. And vendor C supplies 10% or 0.1. And so the total of these 3 here is 1 or 100%. So I have good parts for each vendor, and I have defective parts, or I'm going to say bad parts. And that's actually what we're being asked for. Is if you take a look at the question again, it says if a cell phone was chosen at random and the LCD screen was determined to be defective, so I know it's defective, what's the probability that it was produced by vendor A? So they each have different percentages of defective parts, and they each supply different percentages to the market or to that manufacturer. So that's going to change things up a bit. So the easiest thing to do is this. I know that for vendor A, 0.7% are bad, or 0.007. So we're going to convert it to a decimal, 0.007. And I'll put this 0 in front over here to show the decimal here. So 7% of the 60% are bad. So 0.007, did I do that right? 0.712, I sure did. Okay, so 7% of the 60% are bad. For vendor B, 1.4% or 0.014 of the 30% are bad. And then for vendor C, 1.9% or 0.019 of the 10% are bad. So, if a cell phone was chosen at random and the LCD screen was determined to be defective, what's the probability the LCD screen was produced by vendor A? I could fill in my good part of the table here. I would just do 1 minus 0.007, and that would be the decimal value of the percentage of good components times 0.6. Same thing here, 1 minus 0.014 times 0.3 would be good here, 1 minus 0.019. So high percentages of good parts. But I'm interested in bad because I know that it was determined to be defective. I already know it's a bad part. So what's the probability that it came from vendor A? So, like with probability, anytime you calculate probability, it's the event you want out of the total. So here's the event I want out of the total here. So there's my equation. The probability that it came from vendor A, given that it was defective, so in my parentheses, probability that it came from vendor A, given that it's defective, that's what this bar is here, given that it's defective, is equal to, and this right here is not all that important. What's important is the equation that we get the answer correct. Obviously, if we were working probability all the time, and that's something that you're focused on, that would be important, the way we write that. But for what we're doing right now, let's just get the answer right. So the probability that it came from vendor A, given that it's defective, is calculated by this equation. This event out of the total. And so all I do is I sum up that total. And that's going to go in my denominator of my equation. Times 0.6 plus the 0.014 times 0.3 plus 0.019 times 0.1. And now it's just a calculator problem unless you feel like working this out by hand. But when you work this out, what should you get? Well, I'll let you figure that out. Okay. Now, what if the question was asking, what's the probability that the LCD screen was produced by vendor B instead? So the probability that it came from vendor B, and let's suppose that I know that it's defective. So given that it's defective, what would that equation look like? Well, it would be very similar, except we would focus on this part out of the total. So my numerator would change, but my denominator would stay the same. So 0.014 times 0.3 divided by the sum of all this, and that would give you your probability. All right, thank you for watching.